Hi everyone, today we're going to look at one conceptual question that is from a previous exam. It's a very interesting problem, so let's get started. So when I'm reading this problem, I'm also going to highlight some keywords that's going to help us later on. So an inventor claims that internal energy decreases while compressing an ideal gas in an adiabatic piston cylinder device. Assuming changes in kinetic and potential energy are negligible, indicate whether the above claim is true or false by circling one answer. Then justify your choice using an exclamation to receive full credit. Okay, so just by highlighting these keywords, we can already list our assumptions here. So, assumptions. So it says it's ideal gas, so of course we can make the ideal gas assumption. Also, it says adiabatic. What does that mean? That means the heat going in and leaving the system is zero. So Q is zero. And also, they said delta KE, the change in kinetic energy, and changes in potential energy, delta PE, they are zeros as well. Additionally, other than all these assumptions, there's also one piece of information that I think it's important to notice. It's compression. So what does that mean? So for example, if we have this piston cylinder device, we define this as state 1 and this as state 2 because we compress the air from a higher volume to a smaller volume. So this is state 2. So V2 and V1. From this diagram, we can tell that V2 is smaller than V1. So the change in volume is smaller than zero. Okay, so this is what we get from this compression. So what this question is actually asking us is to find the relationship between internal energy and the change in volume. How are we going to relate these two terms? We're going to use our energy conservation equation. So energy conservation. Okay, so we have delta U plus delta KE plus delta PE is equal to heat from 1 to 2 minus work from 1 to 2. Okay, so be very careful with the minus sign here. And since we made the assumption that delta KE and delta PEs are zeros, so these two terms, they're gone. And also we said it's an adiabatic process, so Q is also zero. This is fun. So we're only left with two terms. Now we only have delta U, the change in internal energy, and also the work from 1 to 2. Make sure there's a negative sign in front of it, 1 to 2. Okay? And work can be also written in terms of volume, right? Pressure times dV. And we said this earlier that the change in volume is smaller than zero, so that means this term is smaller than zero. That tells us the work from 1 to 2 is smaller than zero. And there's a minus sign right here, right? So 2 minus, that gives us a positive. So that means the change in the change in internal energy is bigger than zero, right? The entire whole term give you a bigger than zero, right? So that's telling us the internal energy actually increases while we compress the ideal gas in this adiabatic piston cylinder device. So the statement is false, right? So this is the end of the video. I hope you think this is helpful. Thank you.